Hello.
Ah, hello, Professor.
Hi. We're all virtual tonight. Woohoo.
Heck yeah.
Hmm. Are you feeling any better?
Yeah, I feel awesome.
Okay. Well, that's cool. Seems you got over it pretty quick then.
Yeah, well, I think it started on Thursday or Friday, so I had it all weekend.
Mhm. Oh, well, good thing it's the shoulder season. There's not much that you can do. Plus, you were busy.
Yeah, yeah. Oh, hello, Claudia, David.
Hello.
Lil said she's going to be late. She has some board meeting that she has to attend to, but she will be joining us. And the other reason I made it virtual is Claudia had some work stuff too that ran late. Should make it hard for her to get on campus.
Yeah, I actually like barely made it home, so I would not have made it to campus.
Okay. The first thing I kind of wanted to go over was Blackboard, and maybe you guys can help me with what's going on in Blackboard. I can share my screen. But I was looking at the assignments and oh, I shared the wrong screen. It looks like week 9 is on there twice. Do you guys see where that is coming from?
I do see that, and then the one I ended up submitting was the one that was like linked in the actual week folder. I don't know if that makes sense, but only one of them was linked in the week folder.
Okay. Because yeah, you go to course content and I believe, let's see, week 11 here it has. And this one maybe, I don't know if this one is linked, but where's it located? Where's the linked one where you looking, Claudia?
So if you click on that very thing, like assignment 9, the bold and underline, that's where I submitted it.
Mm.
Okay.
Mm.
Oh,
Yeah, and it's in my grades twice as well.
but I'm not sure where that's coming from, why it's in there twice, because I only found it here once in all of the documents and all of the folders, unless you guys see it in another spot besides week 8.
Mm.
See it in week 7. I don't see it here. Spring break messes me all up. And week 10, I
Oh,
don't see it in here.
in if you hit week 8, it's in mine twice. Yeah, one
Oh,
at the
yeah.
top and then one if you scroll to the very bottom.
Okay.
Um, yeah,
All right.
yeah, there, and then if you scroll to the bottom, yeah.
Okay. All right. So, there we go. Okay. I will delete one of these. The one maybe at the bottom. And then if I send you an email saying that your assignment is missing, just feel free to re-upload it, okay?
All right. Hmm.
Nice. Little housekeeping here. Nope, it's still there. Come on, delete. Because if it's not removed, you guys will get like a 0 out of 50, and that will not be good for your grades. Okay, so now we should only have one available in the homework, and for those of you, yeah, who have uploaded, maybe check that it's still attached there. Okay. So looking at the syllabus, this was due, and then we had another one where you had background, rationale, and then methods. So if we go back to the course content and look at the next week, week 10, sorry. It was through data collections. So have people started working on this one and submitted this one?
Yes.
Okay.
Yes.
This is the one that's due today, is this one. Okay. All right, so that's great. And then for your homework assignment for next week, it'll be pretty easy. So we go into week 11 here, and it's getting to know this GSS. So it's some simple questions about the generalized social survey data. So I actually already downloaded it. Take a look at it. A little bit of break from homework, not so intense. So it's figuring out, getting to know this GSS survey, which we're going to go over in class. We're going to use SPSS and asking you kind of, okay, what does this column in the database mean? Just some general stuff where you open it up and you go through GSS and you kind of learn about that database. The other helpful tool for you in answering these questions is there's a GSS folder in your course content. If you scroll down, there's this GSS here. And you'll see that this is the data file we're going to be using for our class. And we downloaded it last week. David, if you don't have this, please download it, because we're going to use it today. Other David, did you ever get SPSS working on your computer?
I didn't, but I think it finished downloading and installing, but I didn't actually open it up. But maybe I can. That'll just be a couple-minute exercise at this point, hopefully.
Hopefully. Okay. Yeah, maybe try and work on that, because we're going to use it today in class. And when we get to that, if it's not up and running, let me know, and we can take a restroom break and get it figured out.
Okay.
Okay. So there's a code book in here, so the questionnaires that are used for the survey, and then a little bit of background about the GSS. You can also Google it and find this survey online and find out information about it online. Okay. So that will be next week's homework assignment. Anybody have any questions?
Nope.
Okay. All right. Back to content. All right. Okay, so move my presentation if I can to my other screen. It's hiding down here. Come on. All right. Now can you see a PowerPoint?
Yes.
Okay. All right. So today we're going to talk about descriptive statistics and scales. It's a lot to go through, and a large portion of this will be working with SPSS and getting familiar with that. If there's time, maybe we can go through Excel and some tips and tricks in Excel, as far as totaling up counts and things like that, which is, I think, easier to do than in SPSS, but we will see. And so we talked about the homework already. There's quite a few chapters devoted to quantitative data analysis in your research methods for public administrators. So the Johnson book, chapters 12 through 16. We'll be covering them in this upcoming weeks. So there are many different, when people say descriptive statistics, I mean, it covers a lot. Other people call it, basic statistics. When you can't do statistical analysis, p-values, modeling, descriptive statistics can work quite well. either for checking your data or just when you have a low sample size. So if you have like a sample size of 9, there's really not much you can do with it other than descriptive statistics. However, they're very, very important to tell the story of your data. And it's good to get an idea of how to do these descriptive statistics. So you think about when you're collecting your data, what format should that data be in? That would allow you to easily calculate some of the descriptive statistics you think you might want to do. So if you're doing a survey, do you want to have the data, wide format, which means it goes across the screen. So I can maybe do a quick example of that, talking about different types of data. I'll do it in here. So let's say we had data with let's see, low support, moderate support, and high support and spell. Okay, so you have these 3 columns and you just have people that you interviewed. And let's say you built a database where you just kind of put 1s in for when they answered yes to low, moderate, or high, and say the rest was 0s because you don't want to have any blank data, any blank cells in your database. So I'm just kind of quickly building this here. Okay, so here's your data. And this is what we would call a wide format. So it's distributed across many cells. To me, okay, if I wanted to get, what is the total count of people who had low, moderate, high support, this would be pretty easy to do. Okay, this data format works pretty well for that. It might be kind of challenging to do other type of an analysis, where you wanted to have everything in one column. And that's where you might want to switch it to a long format. So for this example, a long format, if you switched from wide to long, would be you would have a column called support. And you would have low. And so, and this would be a count, let's say, or be yes, no. And so only the first 2 people said yes. The rest of the people said no for low. And then you would repeat these same people here. And your next field would be moderate. And so the people who said moderate were P3 through P6. So these guys would get 1s and the rest would get 0s. And then you would repeat it one more time for the high. And only the last 2 people said yes for high. And the rest said 0. And so this is an example of what a long format would look like. This is wide and this is long. And so this format, it would be much more difficult to add up quickly low, moderate, and high support. However, oftentimes when you are running a statistical analysis, this is often a better way to go. When you're making frequency graphs, when you're maybe doing t-tests or something like that, lots of times you have to do it. I want to do a t-test by support. You can't do a t-test or anything by support here because they're scattered across different columns, but you can do it by support because it's all nicely packed into one column. So it's thinking about what you want to do with your data. Does that make sense? The wide versus long format? Has anyone heard of those terms before?
Nope.
Okay. Like R can convert your data from long to wide. So if you do run into this issue, I see students trying to do it by hand. And it's much, much faster to do it with a program like R, and it's a lot less data prone. The more you can automate something like that, the better. So if you do have to do data conversions like that, reach out to me or talk to someone to make your life easier. Okay. All right. So again, getting back to, thinking about what it is I'm going to do with my data. So I think we're all familiar with counts. It's just, counting up the number of times the response happened. Percents is something that's, people, what percent of people responded to low support, high support. Rates gets a little tricky, rates of change. So we're going to go over that. Ratios, rates of change, distributions, and then we'll talk about central tendency measures. Means, medians, modes, things you would do with like age, weight, numeric values, and then measures of dispersion, kind of how scattered is your data. And when COVID was out, there was a lot of good, there was a lot of good databases, snazzy dashboards and stuff that really showed the differences between these types of data. So in this snapshot, you have a lot of counts here. So you have a count of the total of cases, deaths, total recovered, but you also have ratios. So total cases per 100 million, deaths per 100 million. It helps standardize the comparison. And so like places with the United States, we might be a huge country. So we have a huge COVID count. But if you factor in the fact that we're a large country, maybe the count per people goes down. Not really for the US and how we responded to COVID, but just an example. It factors in your sample size. Percents, I think everyone here knows how to calculate a percent by now. Hopefully we're good with that. Number of positive tests over total tests multiplied by 100. Yeah, again, depending on how you want to make your graphs in Excel, what you're going to do with your data, you have to figure out whether you want to leave it as 0.1 or you actually want it to be 10%. Are people familiar in Excel with how to change how the values are displayed, whether they're percentages or whether they're decimal points? Okay. So if we go back to Excel, let's see. Say, copy these. We wanted to figure out what is the total percentage of people that have low support. Make this a little bit bigger. And so low support, it was a total of 2. And we would take the 2 out of the total sum of our respondents. So this would equal 2 divided by the sum of these guys. Close that and hit enter. So we have 0.25, which is, we turn that into a percentage. We right click and go to format cells. Percentage here. And I don't really need to have these decimal points. They're not important to me in this case because I'm going to be dealing with large percents. So don't show them. I don't need to see 25.199 whatever. Use decimal points when it makes sense. That's very important. So 25% of the total people who responded were in low support of whatever issue we're looking at. So if I held this down and drug this, would it fill in these 2 cells properly? What would happen? If I click this corner and drug this down, would it work?
No.
No, I think like start counting up.
Yep, you're right. It would not work. And it doesn't work because this is taking this row and dividing it. This is moving down, so it's moving around. It's not going to work. It's tracking kind of where you go. So for this example, what we would have to do is we'd have to go to 25, we'd have to go to the center here, but we can help with the second part of this equation. So we could put this back up here and you can use dollar signs to keep this from moving around. So if I don't want this to change ever. This is always going to be the total count here. So this box, no matter where I move the cell, should stay the same. I don't want it moving down. I don't want it moving across. So if you put a dollar sign in front of the numbers, it's not going to move up or down. It's not going to change numbers. If I put a dollar sign in front of the text, the letters B, C, D, it's not going to move side to side. So now it's locked in place. So I have to make sure the first part of this is right. So this divided by the sum of that, and we get 50. So if I drag this down, I still have the issue of this top isn't correct, but at least see the bottom stayed the same. So this stays the same. I go in this cell. This stays the same. Have you guys used those dollar signs before to help out with that? No?
I am so sorry. Could you explain the dollar sign thing again? Because I didn't understand.
Okay. Sure. Let me change the way that this data goes because I would like it to look in a different format. So I'm going to go low, moderate, and high. And I'm just going to put these numbers over here so that they're in the long format. So
Okay.
in this example, 2 people said yes, low support, 4 said moderate, and 2 said high. And I'm going to put the total down here. Is going to be the count of that. So it's summing up these 3 cells. Okay. Are you with me?
Yep.
Okay. All right. So let's go back over to our example. If I want to calculate this percentage, I want it to be the number 2 divided by the number 8. Okay. And what I want is when I'm dragging this cell down, I want the top to move because I want this line to be 4 divided by 8. I want this line to be 2 divided by 8. I don't ever want 8 to move. So what I can do now is, we'll use it this way. I want this cell divided by our total count, and we don't want it to move at all, up or down. So I'm going to put the dollar sign right there in front of the number, in front of 16. Okay. And so I'll hit enter. And it's still there. So we're dividing 2 by 8. Now if I come to the corner here and drag this down, the top cell moves, but see, it's still on number 8. It's not changing 16. It's not moving down the rows like this top value is. And this one is also E16. So 16, it's not moving up or down rows because of this dollar sign right here. Okay?
Okay, got it.
Okay. If let's insert something here. If we had an example where this was I don't know, undergrads and this was graduate students, and let's say, you know, we pulled each of these people to see what their support was. And so what if we had a poll of graduate support or undergraduate support and graduate support, and we wanted to calculate the percentages? So we've got graduates, we've got undergraduates, we've got graduates. Now, if I slide this over here, notice how this can move left to right. It can move from E to F because there's no $ in front of the letter. The letter is still mobile. Okay? And so now I can just go like that, and it automatically calculated it all for me. I didn't have to do any typing by hand. It did it. So this has no $ in front of the letter. It's able to move over. And that allows me to just, either copy and paste or move it over. And there it goes. Okay? Are you tracking that?
Yes, got it. Sorry. I don't know why it like didn't make sense at all before, but now it does.
Okay. However, if you were interested in just, the total sample size, for example, you didn't want to divide this only by 8. You wanted to divide it by all of these, a combination of 8 plus 19. So you wanted to take a 2 divided by all of it, 7 divided by all of it. How do you think the formula would look? What do you think it would look like?
Well, I think for this one it would be E13 divided by parentheses E16 plus F16, but you would want to put the $ in front of both letter and number.
Okay. Okay. Is that gonna work? Yeah, that does work. Okay. You could do, what you did, or you could use the sum. So you could do that, or you could do sum. And then highlight these. It's the same thing, right?
Mhm.
Yep, but then you would have to put, you're correct, the $ in front of both the letter and the number, because you don't want it to move or go anywhere, right, left, up, down. And so I'm going to change this, the format cells to percentage. Okay, here we go. Okay, and then copy, and I can actually just paste it. And so you're correct. 8 is still divided by all of those. 7 is divided by all of those. So yes, you've just saved yourself a whole bunch of typing, and it's all done for you. Okay. So can you guys imagine using that at all in your work?
Yeah, for efficiency, definitely.
Okay. Yeah, that $ thing is when I was told about it, I'm like, oh, why didn't I know about this sooner? Yep. Okay. All right. Okay. So percents, we talked about that. Rates and ratios. As I mentioned, it's a way to standardize data and make comparisons. So we'll take a look at this dashboard that's actually still up and running with COVID stuff. They stopped collecting about a year ago. Interesting. And so this is a dashboard I'm sure that you're all familiar with that John Hopkins put together. You can look at the observed ratio here, or you can look at the deaths per population. So for here, they're trying to account for the observed cases and the fatality. So it's a ratio of, when people got it, how fatal was it? And so the mortality was much higher in Peru, Mexico than a lot of other countries. And this is trying to account for the total population. So when you account for the size of Peru per 100,000 people, the mortality rate was very high. And they got some graphs in here. So does anybody have any questions about like ratios and rates? You see them quite frequently. Okay. All right. So I would like you guys to take a look at this Alaska health data. So let's actually deal with some Alaska data. Ah. Yeah. I think I'd rather check ocean temperatures than COVID rates. All right, so let's pull up the Alaska data here. This is some good information on mortality rates and counts here in Alaska. They've moved to this new interactive Tableau dashboard. So why don't we click on the first one here? And there's an overview of it, and you can go to annual trend lines, demographic tables, and leading causes. So I would like you guys to take a look at this data, and I want you to pick what is the most interesting rate or ratio data you can find on this website. We'll take like 5 minutes for you guys to look through the various information that's provided, and then we'll go around and have people talk about which ones that they found to be the most interesting. So how about let's come back at like 6:07.
Okie doke.
Okay.
Among any of the data on the site?
Sure, you can go with any of the data on the site, because some are more interesting than others. Alrighty. So, let's go around. How about California, David? What did you find that was interesting? And you can share your screen if you want.
I'm not gonna do the screen share because I couldn't get Excel to do anything exciting in the meantime. Or I could actually, I'll just show you like the thing that I was looking at. I chose marriage and separation statistics. I don't know why, just among all the death that just jumped out at me as being something I was kind of curious about. Because I mean, it was like, well, what's it gonna show?
Mhm.
How do I scan that? Sure. Um, um, so right now it's showing Anchorage. Let's hop back to Alaska. I don't know, you can like, it's really easy to see some open trends. Here in parentheses, you have rates, which
Uh-huh.
is kind of the only thing that I can wrap my head around.
It looks like it's going up, you think?
Steady decline, actually. So this is backwards in time. So most recent at the top.
Yep.
So actually really steady decline in both. One thing I was wondering was my first question was like, oh, are they going to co-vary? Are they going to have like opposite variance? Are there like times when people are more together-y and times when people are more party? No, they both just seem to kind of just be a steady decline. There's looks like a little bit more volatility in the separations number, but like separations going down makes sense if marriages are going down because there's fewer marriages to separate. I think that makes sense. I don't know. It's my logic button. If you look at a
Yeah.
specific area, it just gets a little noisier, but I don't know if that actually says something or if it just means that like, when you have smaller, I think noise is the right word, a little more random, like a little less clear trends, which I
Hmm.
think happens when you have a smaller data set. So if you look at like just Anchorage, like there's more outliers from the trend. Like 2002, 2001, 2002 were super low. Also like almost the same number. Kind of weird. Also kind of weird that it's so stable, right? I mean, I guess not. That's more a philosophical question. Are people just robots? But yeah, I don't know. I thought it was neat. Thanks for listening.
Yeah, Anchorage should be probably primarily driving the data, so it is, yeah, it's fascinating that there does seem to be more variation within the Anchorage. Whereas, yeah, I thought it would have been kind of more consistent with the Alaska statewide. Okay. Would you know how to copy and paste this into Excel and make a line graph?
So that's what I was gonna try to do.
Okay.
And Excel didn't open in time to do that. But I'm not positive that I could get a line graph in a hot minute. But I was gonna try to do that, but it's all done. That was the plan. So I might keep fiddling with that as we go and see if I can get that to happen.
Okay. Okay.
Is it still screen sharing? Is Excel up now?
I don't see Excel. I still see your rates and marriages.
Um,
We could either do it right now and people can learn how to do line graphs, or we
yeah,
could.
actually, you and Mike, because I do have Excel open with the data pasted in there.
Sure. You could stop screen sharing and then maybe share the Excel file.
Here we go.
Yep.
So this is all Alaska.
Okay.
So if I grab these columns, right?
Nope. Nope. The first thing I would do is put in a header row because that'll make your graph more understandable. And I think that was year. Yep. And then I believe it was marriage and separation.
Yeah.
Okay.
And then
This is a great example.
And then do I need to separate out the rates?
Yes, you have a problem because right now it's not treating them as numbers. It's going to treat them as probably a text because you have that parentheses in there.
Right.
Okay. So what I would do is I would copy that marriage column in the C, and why don't you throw it in column F? Okay, the goal is we need to divide out that 4,000 number from the parentheses number, right?
Right.
So the trick, no, I wouldn't do that,
Oh.
undo.
Okay.
The trick is you need to use this, the separate field. So highlight column F. And then go up to data. Text to columns. Hit
I think fixed width will
hit
do it.
next.
It's all 5
Okay,
characters.
try that. Sure, try fixed.
No, no, we'll go.
Okay, the key is you want to break it out by you could do space. The other option is to do other, where you could use the parentheses. So in that other, you could put parenthesis. Yep. Okay. And now hit finish. Okay, but you still have a problem, like say you wanted column G, so you could run through the exact same process, data. Yep. And then for the other, it's going to be that the other way. Yep. Okay, so now you could call that column F is marriage counts, and the other one is marriage rates.
And then same
Okay.
operations.
Yep, the same for separations. Since you're wanting to make, yeah, go ahead and insert it in there. Since you're wanting to make a line graph probably of the comparison of the counts, eventually you're going to want to have marriage counts together, separation counts together, and then marriage rate and separation rate. But
Okay.
let's split apart the separation column. And so your column D, your separation counts, I'd snuggle that in between B and C. So Control X or however you do it on a Mac, and then insert, click on C and then insert.
Okay. There's this thing I always try to do that I can get to work 10% of the time, where if you hold control and you put the thing in the right spot, you can just rearrange them.
Okay.
But it's not working. So let's just do it this way. Okay.
Okay. So let's check and see if your cells are actually numbers. So in the marriage count, let's click on B2. Is that a number? It looks like it is.
Yeah,
So yeah.
Um,
In a PC, you right click on it. You click on the cell and then right click. Okay, now you go to format cells. And a pop-up should come, and
Yeah,
yes, it is
number.
identified as a number, so you are good, okay? Now, the trick with line graphs is sometimes if you take that year column, which is gonna be your x-axis on the bottom, it kind of messes it up. So what I like to do is just highlight the data that's gonna become the lines. So, click on B1.
Okay, well, one other thing that comes to mind is maybe rearranging it. Because if you want to display this as a graph, like if it's going to go from descending, if it's going to translate descending into left to right on the x-axis, it's going to create like a non-intuitive graph.
So what would you do?
Convert it to a table and sort by the first column.
Well, it is a table right now, so you could actually you could sort it. But remember, the trick with the sort is you want to highlight all of your data so it doesn't get separated. Yep, okay. And now we can go up to data. Yep. And then there's a sort there. And
Give me a-
you have to say my list has headers. Check that box. Okay, and then sort by.
Yeah,
In that first
values
column.
need-
Can you pick year in that first column? Yeah, there. Pick year. Okay. And smallest to largest. There you go. Okay. So now you can highlight all your cells in B, C, and D that have data.
Mhm.
Or
And-
even the titles. No. So B all the way down to the bottom, and then column C all the way down to the bottom. There you go. And you want to do that because right now we only want to have counts on there. The counts are way different scale than the rates. We want to highlight the names because when the lines get drawn on Excel, now it knows what to call them. So now let's insert our line graph. Yeah, chart.
It's going to be a chart. Yeah.
Mm-hmm. Okay. So see, it knew that to call it marriage counts and it knew to call separation counts because we highlighted that. So now we need to put on the axis for the X. So if you right click on it and go to select data. Go to horizontal category X labels. Yeah, click on that. Yep. And now highlight your A2 down to whatever your year, A2. Yep. Okay, hit enter. Hit OK. And there you go.
Nice.
So you made a quick line graph out of the data, grabbed it from the website, and here you go. And you can see, yes, they do sort of mimic each other, but something is going on the last couple of years.
Wow, nice job. That's great.
Maybe COVID prevented, I don't know, marriages, and now people are like, yeah, baby, let's get married because we can have our ceremony or whatever.
Or just regression to the mean in 21, possibly.
Could be.
Or just-
Yeah. I think more likely that's a glip and people postpone their marriages because people couldn't get together and celebrate. I bet that's kind of what's going on. People can separate all the time. There's no ceremony for separation.
Yeah. I don't know why, but you're right. There is
Okay. Claudia and the other David, is this helpful for you guys to see how to do this?
Yeah, that wasn't as hard as I could would have thought. Yeah, good job, David.
Putting you on the spot. Yep. And there's your mortality rates with a wildly different scale.
the rates are going to look exactly the same. It's just on a different scale.
Yeah.
Cool.
Okay.
All right.
All right.
Thanks.
Cool. Good job, David. Let's see, Claudia, what we'll have David stop sharing screen and see what Claudia found interesting.
Okay, I cannot share my screen on this computer and I don't know why. I can try the other one if you want me to.
You could put the link in the chat and we could pull it up. I could pull it up
Okay.
on my screen.
That works.
I see
the one-
Lil has joined us. Lil, we're looking at Alaska Department of Health data.
I think that should, nope, that might not work. Okay, I got an error message.
Well, it brings up the whole data set. What specifically
Okay.
did you look at?
So I am looking at crude. Nope. I'm looking at I was much more morbid than David was, and I was looking at deaths with drug-induced underlying causes. And I specifically wanted to wanted to focus on the demographic of race, but there's like a lot more demographic categories.
Okay. So did
and-
you do drug here? Is this what you did here? Annual
I
trend
think
lines or?
I see SPSS on your screen. I don't see the
Oh,
website.
okay. I'm sorry. Sharing the wrong screen again.
Okay, so I clicked on where it says cause list. I clicked on 3. And then if you go to cause categories, yeah, it's kind of funky. Go through 1 through 5. Because I wanted to look at all of them.
Oh boy, that's not a good line.
And then for demographic, what did I put? So demographic, there's an option if you click on it I had an option to select all. Oh no, what I did was I first looked at race and then I'll show you guys the other thing I did. So first race.
Okay.
And then I looked at this at first and I was like, oh, only white people are dying of drugs in Alaska. That's weird. But then when I when you click on measure, and what I looked at first was crude death rate.
Yep.
Now
And why does
you
it change
see
so much?
the disparate impact. Because there's a lot of white people in Alaska. So just because there's a lot of white people dying because there's a lot of white people, they're not all necessarily they're not necessarily all of the people dying from drugs. And there's comparatively less Alaska Native and much less Black people living in Alaska. So that's why the lines change so dramatically when you change it to rates, which I thought was really fascinating because like I said at first I was like, oh, only white people die, and then no, it's not true.
What does it mean to change the measure to crude?
So I guess I had a hard time understanding because the option was either crude death rate and age adjusted death rate, and to be honest, I didn't really understand the difference. When I clicked on it, the line seemed pretty similar. I'm not sure if with the age adjusted, they're controlling by the average age. Oh,
that's my
cool.
next slide, is to talk about this age adjusted rate. So the one is they're controlling for the total population. So you're right, there's a lot of white people. So hey, they're the ones dying. Well, actually, when you look at the proportion of white people versus say Alaska Natives, other races, a bigger portion of other races are dying due to it looked like drug deaths. Age means that you adjust for the age category. So you kind of have a standard population. And so you adjust for that standard population. So here's an example. I find it easier to look at an example. In this example, you're looking at deaths, and you're breaking them out by age. And so you can see that the rates of people dying is lower among young people. And as you get older, the rates of dying increase. Well, you have to adjust for how many people are in your population. So, typically there's a lot more, younger people. And as you get older, there's fewer older people. So 85-year-olds, even though they might have a really high death rate, they make up a very small portion of the population. And so if you don't adjust by that and you treat everyone as an old person with that same death rate, it's going to really skew your results. So when you're weighting things and adjusting for the age, you're adjusting for what portion of the population falls within that age category. And in this example, if you didn't adjust for age, you'd have a rate of about 230. When you do, it drops down to, 214, 15. So that's what's happening when you do the age adjusted rates. You account for the size of the population within age. Does that make sense now?
Okay, yeah, that's kind of what I thought it was, but very interesting. Yeah, I
Is-
think I'm interested in kind of like exploring this data more
Mhm.
because with this particular data set, when you click on age adjusted, there's like some slight movement, but it doesn't really change. So I guess I'm wondering if for other causes of death, it's different.
I would say, mortality from drugs and alcohol definitely does affect age groups differently. David, what was your question?
That I think what we're doing here is adjusting for the fact that like mortality rates always vary between age groups, and is that what we're adjusting for? I'm not grasping exactly how it's being accounted for, but I want to at least make sure that I'm getting the right idea. That basically
We're-
like deaths of people that they would expect to die anyway are counted as fewer.
Well, you're kind of adjusting for the fact that there's different death rates among the population, and there's a different distribution in the count of the population. So not only do they die at different rates, but their distribution within the population looks different. Does that make sense? It's a two-factor kind of adjustment. Think of like if you had a community that had a lot of young people in it, a lot of
Mhm.
young people, and you applied the death rates based on your age. So you appropriately account for the fact that, younger people have a lower death rate, older people have a higher death rate, and you have another community where it's actually a bunch of old people, and if you apply the same rates and don't adjust for the size of the population, the distribution among the age categories, you're going to get the same results if you don't do that. But if you adjust for that age distribution in each of the communities, then you would get a more proper, let's say, death rate.
Okay, so in this example, column D, that weight is obtained by looking at what the death rate due to cancer is within that age group.
No, this column here is the population size distribution. So it's the adjusted weights used in the age adjustment of cancer data within each group.
Okay, so wait, I do think I get it. When you have the age adjusted rate is what would the rate in our population be if our population was equally distributed among all these age categories?
And how's it's kind of skewed. Yep. Yep. So, it is kind of a tricky thing to do. And, but it is an important thing to do. And so when you see people presenting results, age is, as I mentioned, commonly a factor that influences results. So if they haven't adjusted for age, then you should be throwing up the red flag in their methods and, is this really credible result? Because as going back to the beginning of the course, I don't expect everyone to be statistical wizards at the end of this or even know exactly how to do it, but to be aware that, hey, this really does need to be adjusted for age. When you're talking about a lot of health issues, it should be there. Oh. Okay. So going back to your example, that's why you will see the age adjusted, death rate here, because that needs to be done. It looked like there was a slight shift. Okay. Awesome. Let's see, David. Other David, what did you choose?
Yeah, here, I'll share my screen. Okay, so I went to leading causes here, and I was just trying to, at first I was looking for patterns or with leading causes of death. And at first I looked at self-harm because maybe leading up to COVID, it maybe this is just high, but then as I looked further back, it wasn't really, it didn't really change much at all. But as I kept going through the years, and I looked at every year for since 99, and the top three stay the same. It's always number one is cancer, two is heart disease, and three unintentional injuries. No matter what. And then once you get past these three, then the next top 10 are subject to change based on the year. Yeah, I just thought that was quite interesting that no matter what, these will stay the same.
Did
And
you
even the
look at the years of life lost? So if you keep a measure? I thought that was interesting. So do you know what that means?
no, what does that mean?
So it means accidents typically kill younger people, people with a lot of years left to live. So those
wow.
accidents take away future workforce, future parents, things like that. So when you're talking about life lost, accidents are the most important.
Yeah, okay, wow, that is really interesting. Yeah, accidents and then yeah, cancer and then heart disease do drop there, I see. And then
Self-harm goes way up, yep.
yeah, self-harm does go up. Yeah, self-harm on this one is
You're back to deaths. It's, almost nowhere to be found.
yeah, nowhere to be found, but then in 2019 it's number 2.
Yeah,
Yeah.
which indicates it's a big problem among youth.
Yeah. Yeah, so it tells a lot. Yeah, interesting website.
Okay. Okay. Lil, you're in the health profession. Do you use the website a lot?
Yeah, sorry, I hope you guys can hear like the background noise I'm running past you right now. But yeah, I've used Tableau before, especially when I was working alongside the Justice Center at UAA, because they had that, so not healthcare, but it was the population dashboard for DOC, Department of Corrections. And an interesting, like just random note, but like just reading the tableau that that David just showed us, it we have like similar dashboards that we use to put together like community health needs assessment, especially if we're looking over different spans of time, different types of data. So pretty familiar. I wouldn't say I'm an expert though.
Mhm. Okay. Yeah, Tableau, I have a love-hate relationship with it. They used to just have CSV files that we could download and do wonderful things with, and now it's good visualization, but sometimes it makes it difficult to access the raw data. Yep. Okay. Okay, all right, so let's try and get through this rate of change here, and then we could take a break. So the rate of change can be quite confusing for people. I know I kind of struggled with this back when I first started. So you're kind of looking at the rate of change across time. And the way that you calculate the rate of change is divide the newest data by the older data. So the most recent year by whatever year you're comparing it to, and then take that result, subtract a 1, and then multiply that by 100 to get the percentage change. So let's just take an example of COVID here. Say in August 22, you had 498 cases. In October, you had 1,101 cases. So you take the newest divided by the oldest, and that's equal to 2.21, subtract 1, and then multiply by 100. So you would say that,
Dr.
the
Shay,
average case
are
rate
you
has increased.
sharing a screen?
I think so. Did it go away? Ah,
Yeah, I
It
only
went away
see
for me.
It went away.
us.
okay.
Sorry.
This is why I don't do
Thank
Zoom.
you. Thank you, Lil. I think the rest of us were not sure if it was about to pop up or what.
Thank you for calling that out. So sorry. Divide the newest data by the older data, subtract 1, and multiply by 100. So with this example, as I was saying, the newest data would be 1,000, cases. The older data is about 500 cases. So divide those two, get the result, subtract 1, and then multiply by 100. So in the 7-day average case rate increased by 121%. So some people might say, oh, it's 21%. No, it would be 121% increase. So what I would like you guys to do is work and with Excel and figure out what is the rate of change between, I wanted to do kind of after with the COVID effect from 2019 to 2021, and then taking a similar time range, 2016 to 2018, using this website. So it's again the dashboard here. Demographics table. And let's see, get this 17. Okay. Let me see if I can collapse this to make it better. Let's go by sex since that's pretty easy. Okay. So this will give you some challenges. I would like you to Tableau does have the option of you can download this. So you can download this and open it with Excel. I want the rate of change for all people. So you're going to have to add up males and females from 2019 to 2021. And then I believe the other one I said was from 2016 to 2018. So I'll put the link in the chat here. And then I'll let you guys pull up the website and see that. And then I can flip back to show you the formula. So I think you guys all should have the website, but if you don't, there you go. So many mortalities open. Okay.
Is anyone else getting the problem that they can only get data between 20? Oh, never mind. I think I fixed it.
Okay.
No, it's actually happening to me. It only goes up to 2020. Is anyone else getting that?
That was happening to me, and I think it was because like I was trying to get there on my own, but if I clicked the link that Dr. Schmidt provided, it did give me 2021.
So Claudia, were you able to get what I have on my screen on your screen?
Yes, I was able to get it now, but before
Oh.
I was like I wasn't, and I just clicked the link you gave me, and then it worked.
David Clyde?
Yeah. Thanks, Claudia. I just did the same.
Okay. David, California, do you got it
Yeah,
now?
I got it as
Okay.
well, but I don't know what happened, but yeah, I had followed the link that Claudia had put in the chat. So whatever happened to her happened to me.
Okay. All right. So, yep. Use Excel to figure out the rate of change between the two different time points I have. And a little part of today's exercises is, we're going to be learning about Excel and kind of, how to use Excel and some of these basic descriptive statistics. And then we're going to start getting into SPSS and learning how to use that. Will you be home to be around a computer?
Yeah, so I should be home in about 15 minutes. I'm very close.
Okay.
Yep.
Is when I go to download data, it kind of gives like a complex, I guess what we would say like a long form table.
Okay.
Does anyone see a way to download the wide form?
So it's giving you a table like you see on the screen.
Yeah, it's arranged more like that.
Okay. This would be an excellent exercise to play around with pivot tables. Does anyone use pivot tables?
No.
Yes.
Yes.
Okay. So if you'd like to get that into a different format, a pivot table would be a way to go, and we can walk through that too after you guys play with it for a little while, work with it here. And maybe when you get the rates calculated, if you've got it done, maybe put your hand up in the chat. That way I can kind of see.
Before I go too far, can I confirm you wanted us compared, 16 and 18? Oh, thank you.
Claudia, you had your hand up. Are you done or did you go back and redo it?
Um, I I am done. I'm just double checking to make sure I did it right because I feel like nobody else is done, so maybe I did it too fast and I did something wrong. So that's why I put my hand down.
Okay. But if you wanted to send your answers to me like in a direct message, I can tell you if you're wrong or right.
And I wanted to check, did you want us to do it from the uh like did you want us to download the data and then do it there? Because I didn't. So I'll go ahead and fix that too.
Yeah, I want you to pull it into Excel and then in Excel, figure out the rate of change from 2019 to 2022, and then that same data, the rate of change from 2016 to 2018.
Okay. Okay. Let me do that now.
Because that'll give you practice with Excel. And also David
Mhm.
brought up an excellent point that it's not really the best format.
Yeah, it's really ugly. That's why I didn't want to do it. Thank you.
But that's data. Okay, everyone done? Okay,
No. Wait, could I see someone else do this really slow? Um, one more time.
okay. Who wants to show off? How about let's have Claudia go this time? If you feel confident. If no one feels confident, I can go and go slow. Or do you
I can't
confident?
share my screen,
Oh, that's right.
but I'll
Dang
try
it.
to I'll try to explain what I did verbally, and hopefully that works.
Okay.
So my first step was to take male and female and add it together to get a total, and then I like went off to the side and I did like a separate table, kind of like in the long format where I did a list of the years, and then like male plus female on the other side. And originally I had tried to do like a formula that would allow me to scroll down. But I realized that the female data had been like coded kind of weirdly because for 2 years the number was exactly the same. At least that's how it downloaded on my thing. So that messed up my plan, and I kind of had to go back and double check and make sure that all the totals were correct. So that slowed me down. But once I got the totals, for the first one, I did, well, I'll like put my formula in here. And Q9 was my total from 2021, and Q7 was my total from 2019. Then it was over 2 years, so I divided by 2.
Okay. I guess when you're looking at the formula, let's say, that's coming up on the screen,
Okay.
why did you divide by 2?
Oh, I'm sorry. I did like a raw rate instead of percent change. My bad.
Okay,
No, that was me not listening to instructions. I'm sorry.
okay,
I did the
Can't
same
fix
thing.
okay, okay. All right. So I calculated the percent change, and I can kind of show slowly how I did it. If I'm going too fast, please let me know. I'm like a fast clicker, I know it.
Hey,
Okay, so everyone's raw data should look like this, correct?
Yep.
Okay, this is a horrible format for this
Mine
data.
did not look that way.
Oh, really?
Oh, sorry. Yeah, mine. I wish I could like take a screenshot or something. Mine was like kind of staggered. It had the years staggered. I don't know how else to explain this, but I can't
Okay.
share my screen. But it did not download that way.
Okay, yeah, it might have been inset or something, I don't know. Well, mine downloaded like this, and I wanted to get the total number of, this measured value for each year regardless of sex. So I just used a pivot table to automatically total it for me. So I'm going to delete my pivot table and show you how I did that. Did anyone else use the pivot table function? No? Okay. So what I did is I highlight my data and I go up to insert, and there's this tool called pivot table. Very, very, very valuable tool. So I choose that. And so it's going to do a pivot table based on this data that I've selected. You can either have it put into a new tab, a new worksheet. So it would pop up in a new worksheet here. Or you can have it be created within this existing worksheet. And since it's pretty small, I just want to do it where I can see it. So I'm going to choose existing worksheet. But then you have to go and select like a cell in your worksheet so it knows where to plop it down. So I clicked on a cell and I hit OK. Sure, overwrite stuff. Okay. Interesting. Okay. And so now you see I have all the columns here of my original database. So if I scroll back over, I have demographics, demographic, year, all of these. Okay. So now I can start rearranging my data from long to wide and summing it up. So what I want is I want a table where I have the years going down, and then for each of those years, I just have a count, a sum of this measured value. So I take year and drag it to row, and I take measured sum and drag it to values. And poof, who cares about sex? It added up across both sexes, the total count for 2014 in every single year. So I have my data.
Wow.
One thing about pivot tables is you saw they can easily get messed up and they go away. It's kind of like it's temporary data. So my rule of thumb is if you created a pivot table and this is the data you're going to use to make a chart or a table, always copy it and then, find a safe place in your Excel file and paste values. That strips away all of the fancy coding that's going on in your pivot table, and it keeps your raw data. So now I have my data saved, and no matter what happens to my pivot table, if accidentally, I turn this off and now my pivot table is gone, who cares? I've saved my data and I have it. Okay?
Okay.
All right, so then for the rate of change, I have the information that I need. And so I'm just going to copy this over here. The rate of change for 2016, I'm going to break it up into the steps. It would be, what would be the first cell? That I click on?
2018.
Yep, it would be B24 divided by,
B20, no, divided by, oh yeah, B22.
yep, divided by B22. So that's our first step. And then equals, we take that value minus 1. And then we take that value times 100. So there was a 1.4% decrease in deaths between 2016 and 2018. And kind of the same thing for 2019. So it'd be 2021 divided by 2019 equals this minus 1 equals this times 100. And there was a 34% increase in deaths between 2019 and 2021. Okay.
Wow. Okay. Nice.
The nice thing about pivot tables too is, say, what if I asked you, hey, I want you to break it down among sex? We can easily come back to our pivot table and we can put our measured values back here, but let's drop sex on the top. And so now we have it broken down by sex, and we can go through the exact same formula. I would just copy this table over and paste it because I want to keep it. And then copy and then paste, and then we could just change where this goes. So this would go over to the males. This would go over, let's say this would be the females. So 2016, 2018, and this would be males. And this would be females. And there, we have our answers. We only had to change this cell because all the rest are auto-populated.
Wow. Thanks. I can you please record this or post the recording of this class afterwards too? I would love to look at this a few more times to really get it.
Yeah, it's recorded and I always post my lessons, these recordings to each week, so you'll have it.
Awesome.
The thing that's interesting about this is this points out why I never, ever, ever think it's a good idea to just compare a single year to another year. Because there can be so much interannual variation. Especially like I deal with moose hunting. I mean, you could have snow come and it's a bust year. And, you know, there can be all these factors that affect a single time point. So I like to take averages. So I might take what is the average deaths from a couple of years minus the average deaths of another few years, rather than depending on a single time point. Because I think that's very scary. So it's better to do an average of a group of years when you're comparing rates of change. Does that make sense?
Yeah.
Okay. Okay. Does everybody feel confident that they could do a pivot table? You want to try and practice with it?
Yeah, a little demo with the pivot, another little demo with the pivot table would be cool. I would like to practice with it.
Well, we've been going for a while. How about we take a break until 7:20 and you guys can play with this data. I'll leave my screen up so you can kind of see what it looks like. I'll take off the demographic because that's just makes the data a little bit harder. And so you can kind of see how it works and see if you can replicate it. And we'll come back at 7:20 with the break and kind of see how people are doing. Alil, do you need access to this data?
Yeah, so when I logged back on, everything, all the links are gone from the chat, so.
Okay. Let me give it to you. And when you pull it up, we are going for this demographics table, just single race deaths. And you can download it with that little download button in Tableau.
Okay.
Okay. I'll put the Excel file back up so people can see it. There you go.
Anybody else only able to get crazy nonsense in their pivot table? Like the sum of years, for example?
Yeah. Oh, sorry. I have the hiccup, so that's why I'm not talking. Um, I had the same problem, which is why I didn't try to do it when we were doing the assignment. Sorry.
Sorry, what is the prompt for the exercise?
We're supposed to be trying to. Sorry, I don't want to hiccup. We're supposed to be trying to make a pivot table with this data.
Yeah, make a pivot table with his data, and what we're trying to do is, what is the rate of change? Calculating two different rates of change from 2019 to 2021 and the rate of change from 2016 to 2018.
Well, thanks.
Yep. And we'll go over it because it sounds like some people are getting some nonsense stuff, which is fine. So if you aren't getting it, I would just kind of step away and take a break, and like I said, we'll join back here at 7:20. All right, David, let's have you share your screen and see what's going on.
This one, this David, me,
Yep.
David. Cool. Boom. All right. So 1,000 things we got here. All right, so we're all looking at Excel.
Yep.
Great. Okay, so here. Oh, well, I mean, now it just fixed itself because you're all looking. Like, that's not cool.
Well, I mean, it's not fixed itself. This is the raw data, right?
Right, but like at least it's all here. Okay, so what I don't know is how to get my little menu back though. So I had this menu where I could select things
Mm-hmm.
before.
That's because you're on your raw data. What you did is you did the option where you put your pivot table in a new tab.
Yeah.
So go down to sheet 2 or something like that. Let's look at your other sheets.
So
Yes, okay.
here's just like the regular table that I drew it from.
Yep. So that's your raw table. Click on your pivot table 2 there. There you go.
Right. Well,
Okay.
this is a different one because I made a table like 3 different times in order to sorry, my global protects in my way. I want it to be smaller so I don't have to see it. There we go. Right, so like this one, if I click say year and measure value.
No, no, no.
Oh,
Look at where the year went. When you click year, is it
Uh-huh.
supposed to be in that values column?
It's supposed to be where?
Where's the year supposed to go? Visualize what you want your data to look like. You want the year to be in rows? Do you want the year to be in columns? Where should that year go?
Columns.
Okay, nope, nope. You want it to be a row. Each row should be a year, right?
Each row should be a year. Yes, the years should be arranged in a column.
They should be arranged in a column, but it's actually rows. So drag year down to rows.
Oh, gotcha. Cool.
Yep. Before it was showing up in your values square. You didn't want it in the values.
No. Okay, now it all makes sense. Now I can do every I get what this thing is now. Cool. Um Super cool. So yeah, that we're gonna take year and we're gonna take the measure value. That's gonna be
In your values.
that's gonna be in values.
There you go.
And there we go.
Mhm.
Okay, incredible. Wait, so if I wanted to split it into the demographic options,
That's your second demographic there. That demographic. Yep.
right? So
Drag
I
that.
would go in value. No. Yeah,
Columns. Columns.
columns.
And see how it puts it makes columns out of that.
Uh-huh.
That's why it's called columns, because whatever you put in that, it's gonna put it in a column. Versus
Okay.
the rows, whatever you put in that, it's gonna make each of the values a row.
Okay. And then if I had another thing here that was like not deaths, but maybe I don't know, like number of oranges eaten, like that would also go in values. And if I drag that into values, then I would also get a sum column and 2 different demographic columns.
Sure. So why don't we just delete this pivot table? So I'll highlight the rows J through M and delete it. Okay, in column I, put number of oranges. And then just put various numbers down.
Mhm. Uh,
I would put times 1. It's, yep, the asterisk, there you go, yep. Interesting.
It's because there's an X in there.
Okay,
Now
I would copy and paste those values as real values. So we can get rid of the formula, because that'll mess with us. Yep. Okay,
Um,
before you do that, highlight
Uh-huh.
those
yeah,
numbers. You can't really eat half an orange. It'd be very weird to eat 1/16 of an orange. So under that, in the general, see up at the top, it says general. And it has those little arrows with the numbers going left and right. The general drop down under tell me.
oh, yeah,
Click those numbers. Not in general, click below it. Click, yep, click.
decrease decimal.
Yeah, get rid of the decimals. So click, click, click. I don't remember whether it's that side or the other side. Click to make it the decimals go away
Okay.
because they're nonsensical. There you go. That's more sensible data. Okay, yep. Now we highlight everything, even the labels. We need the labels, okay? Okay, so say we wanted to total up now the total number of deaths and the total number of oranges eaten for each year.
That's definitely gonna go in values. Measure value suppressed is gonna be values. And for each year, it's gonna be rows.
Mm-hmm. There you go. So you can total them both up. Yeah,
Mm.
very easily. Yeah. And then if you're wondering among the sexes, if you wanted to break it up by sex,
That would be in columns.
mm-hmm. If you go back to your pivot table, like where you can make your values selected, so click in the pivot table. You can change the order of in the columns. Say right now you have oranges of eaten and you have male and female. But say you wanted to have all the females together and then you wanted to have females, oranges eaten, deaths, switch the order of the demographics and the values in your column. Yep. So you can play around with how your table still looks, you know, depending on what type of summary statistics you want to do or tables you want to make. It'll influence what order you want those to be in.
Wow, we should see if there's any like association between eating oranges and death. Now that we have this fantastic data, we could do a real study here.
You could definitely, you could have at it. But are they California oranges? Come on.
You know, that's we're gonna need another column.
Yep, yep. Okay. All right. How about other folks? Florida oranges. Uh-oh, we've got some wars going on here. All right.
I wanted to know briefly, how did you guys download the data? Because I got it in this totally unusable format. Like, I wish I could share my screen, but it literally makes the years look like a staircase. So I'm wondering if I just don't know what to click.
Okay. We'll go back to it here. This little download icon here, I clicked on that. And then I
Okay.
clicked on data.
Okay.
Let's see. What did you do to me? Let me try it again. It might be kick me out, making me refresh it because I've had it open for a while. We'll see what's going on here. Sex.
So when I
Download.
download this data, it opens another window. And then yeah, the download button. It
Download.
downloads, yeah, it downloads as a CSV, and I would have to convert it to an Excel. What is XLXSX? I forgot what that stands for. But an Excel file, yeah.
Yep. So, yeah, this is a
Okay.
very common CSV format. I know on all of my computers, let me see if I can do this on the fly here. Is it properties? Let's see. I have it to show extensions because it can get very confusing if you can't see the extensions on your files. So like in Windows, I just went to folder options and there's an icon. Usually this is checked, this hide extensions for known file types. And it gets very, very tricky with Excel because you can't really see what type of file this is. So I always uncheck this so I can see my extensions. And CSVs generally can automatically be opened just in Excel. And then one big thing to remember about this is if David goes to save what he did, he's going to lose everything. If I go to save this as a CSV file, it's all gone. CSV files do not save actions by Excel, fancy actions like this. They don't save charts, they don't save formatting or anything. So you have to really make sure when you go to save this, you save it as an Excel file. So you've got to go here and you have to change it from your CSV and change it to that .xlsx. Otherwise, you will lose everything. So now when I open this up, it will be saved. Whereas if I saved it as a CSV, it would be gone. So I've accidentally done that to myself before, and it's very frustrating to have to redo everything. And it's the same thing with tabs. CSVs will only save one tab. So if you make multiple tabs down here, it will all be lost. You need to save it as an Excel file. Okay. And if we go back to this area and we take a look at this folder again with these files on it, now you will see there's an Excel file and there's a CSV file. And I can easily see the two because of the different extensions. So that clear things up. Claudia, is it downloading for you?
Yes, and I realized what I did wrong. For some reason, I decided to click crosstabs instead of data. I don't know why I did that. But
Okay.
that's where I went wrong.
Okay. All right. So a lot of work with Excel. But now we know how to do pivot tables, which are excellent. We know how to better use formulas, and to make sure to save things as Excel files. All right, another thing is frequency distributions. So you can count up frequency distributions. I'm sure we're all familiar with this. Count up all the choices within a single variable. They can be expressed as, percent, distribution among various categories. One thing that's important when you're doing frequency distributions is whether you really want to include people who didn't respond. Typically, you don't want to include people who didn't respond. If they didn't answer the question for any reason, then don't have them be your total sample size. That will mess you up. It's different than, excluding people who NA, they didn't know. They put down they didn't know, but if they didn't participate, you need to throw them out. And that's important when we get to work with SPSS, that you remove those people from your calculations of what percent of people answered the question this way or that way. And so with frequency distributions, I think, I can show you some tricks with that in Excel, since that's what you'll more commonly have access to. Let me see. Let's see. How about I'll take religion here. Okay. So we have this data set that has religion. So okay. And these are people who are reporting what religion they belong to. And we can just participant. And I'll just give them these like a participant ID. Just so it kind of makes more clear that we have participants. All right, we have 348 people who have responded. We want to get a frequency distribution of the various types of religion. Okay. So one tip with Excel that I always like to do is I can add a field called presence. I usually just call it pres or presence. And so I'm going to put a value of 1 for every single row in this database. So it's 1s all the way down. And it's just presence. I'm going to use this so I can count up the number of times people said Native American, Protestant, Catholic, none. So what I do is I highlight my entire data. So it's all selected there. And again, your magic pivot table comes into play. So I'm going to insert a pivot table. There we go. And if I want to count up the number of different responses for religion, where should I drop and drag things over here? Tell me what I should do.
Rows are going to be religion.
Yep. Rows are going to be religion and
I guess presence will be values.
yep. So it's going to sum it up. You know, imagine if I had age as a category and I wanted to know the average age, you know, among people's religion. You can always click on this and you can edit it to take the average, figure out what the min is, the max. You can standard deviation. So you can play with the statistics that come down here in the values to be something besides counting them up.
Okay.
In this case, we want to count. Okay, so now I have the total presence. And so this is a quick, dirty way to count up the number of religions in our database. And I'll show you why I do not like to do Excel files based on pivot tables. So I'm just going to do what I don't like to do. I'm going to highlight this and I'm going to insert a bar graph. And so here's a quick bar graph that shows the count of the number of people who responded various religions. Protestant is clearly the dominant religion. I don't like to do this because it's tied directly to this data. And look at this. It's just, it's messy. And so if this gets changed for some reason, you know, my table is gone. I've lost my table. So again, it's very dependent on your data here. You can, if you had a filter and say we had a sex filter, that would pop up in here and you could filter your table based on the different sexes. So, I mean, it can be helpful, but I, in general, like I said, don't like to do it. So I'm going to copy my data and put it down here. And I'm gonna call it something more useful than row labels, religion. And I'm gonna call this count. And if we wanted a percentage distribution, what am I gonna divide by to get the percent of people who reported Buddhism? What cells?
F34. So are you saying you don't like using pivot tables at all, or you're saying you use them to convert information, but then you don't like to keep things in pivot tables? You just copy
I
it
don't
out?
like to keep things in pivot tables. So like, okay, I just figured out the percentage, and so I can clearly and easily see that I'm F1 divided by the total to get the percentage. Let me format this cell just to make it a percentage. I'll show you what it looks like off of the table. In this case, we need lots of data. So if I did the pivot table, it'd be equal this divided by this. And see how this formula is very awkward
Yeah.
and it's very dependent on that table. It works. I love pivot tables to get my data and get it in the format that I want it to, but then I save it away from the pivot table for safety reasons. Does that make sense, David?
Yeah, no, that totally makes sense. I was just making sure that I understood you correctly, because it kind of, I wasn't sure if you were just advising us not to use them.
No, use them, definitely use them. So then, since, I used our dollar figures, like I showed earlier, I really only need it because I don't want it to move up and down numbers. I can easily get what is the total percentage. And now I can highlight these two columns here. And I can make a bar chart showing the frequency. Which it's nicely scaled between a more reasonable range, whereas the range is pretty high. I can hardly see Hinduism, Christian, others. I can see it a little bit better here. And then another thing, when people make charts, this is a ridiculous amount of decimal points to have in your chart. You can highlight your axis, click on it, and get that, right click, and go to Format Axis. And we can go down to number. And I don't need 3 decimal points. I don't really need decimal points because that's not helpful with my axis. So this is like a frequency, histogram of how often these different religions occurred in your data set. Have people made frequency charts like that before? No? Okay. Would you guys like to try? Or move on?
So sorry, so that's why I keep muting myself. I have made these before, but I think Google Sheets is totally different than Excel, because I've only ever used Google Sheets, and this is like totally unfamiliar to me.
Okay. Yes, a lot of younger people use Google Sheets. Google Sheets is limited in its power. And usually when you're using databases, you kind of get away from Google Sheets. Yeah. Okay. All right. Well, we can move on. This is all recorded, so you guys can go back and look at it. The other thing we wanted to cover is central measures of tendency. So kind of getting away from categories and into numbers, integers. And basically these are different ways to represent kind of the center of the data. basic, 101 statistics, mode, median, average. I have in here a little cheat sheet as far as whether you have discrete data or continuous data. Do anyone remember what the difference is between discrete and continuous?
Number of oranges eaten should be discrete.
Yes. Exactly. So it's kind of, I'm eating all of the orange. I'm not really going to deal with a half an orange. No one's going to want to eat my discarded orange. So yes, a whole number. You don't kill half a moose, you actually kill the whole moose. Whereas continuous can be weight. It varies. And then nominal and ordinal. Ordinal was kind of like Likert scales where you have an order from good to bad. Nominal is like sex, there's no good or bad. It's male, female, non-binary. There are discrete categories. And then interval, ratio, we just talked about those, like sex ratio, things like that. So this is kind of a little cheat sheet of when you use the various mode, median, medians. And this will be very important for SPSS because sex is actually coded as a number. And I have had students give me what is the average sex. And know that that doesn't work. So really think about your data. Here's an example of the modes medians, how different skews in data can affect the relationship of modes and medians. If your data is highly skewed, a lot of people tend to prefer using the median value for highly skewed data. But they'll pull it left, pull it right based on the skew of your distribution. Standard deviation, Standard deviation, this kind of just shows it's the variability in your population. If this was heights, range would be your min and your max. And then interquartile is a way to look at your lower 25% versus your upper 25% and kind of looking at the spectrum that falls within there. So quartiles are something that sometimes people use for looking at that. I'm sure you guys have all heard of variance and standard deviation. They're very much related to each other in their equations. The standard deviation measures the spread of set of numbers from that mean, that average. Whereas variance kind of looks at the differences between the mean and each data point. So it's a subtle difference, but something you should know about. And then I put in here the equation so that you guys have it, basic statistics, and you can kind of figure out how the variance is calculated, how the standard deviation is calculated. In all of these, you have your value minus the mean. So it's looking at how far is your value from the mean of the population. That's kind of the important point when you're thinking about variance and standard deviation. Okay. All right. So let's see. Talked about this. Crosstabs was one that just came up. Claudia, you stumbled upon it. Crosstabs is a very powerful way to look at more details of distributions. And if you wanted to analyze two variables at the same time, we sort of did crosstabs in the example with the year and the sex. You could imagine that maybe the other, instead of year, you had race. Pivot tables will do crosstabs, so you could look at combinations of race, say, times sex. If you do more than two variables at a time, it can get very confusing and out of hand. Like a three-dimensional table, yeah, very confusing. Okay, all right. We don't have much time left here. Were you able to get SPSS working, David? Okay, all right. So I would like everyone to open up SPSS on their computers. And you should have that data set that I provided last week. And open that. So many tabs open here.
What is it called? What is that data set called?
It was like 2018, so I'll go back to the folder here. We're looking at 2018 data, so I think, oops, shoot.
Okay.
Survey and
I have the
sampling.
file as GSS 28.
Gotta find it. Yeah, GSS 2018 is what it should be called. Right here. Sorry, it's in your GSS folder and it's called GSS 2018 SPSS file.
Is that in the content from last week? Probably. If I don't, if I
It's
can't
in the
find-
folder called GSS. So under course content, there's a folder called GSS.
2018. Great. Okay.
Yep.
Thank you.
Yep. Other David, were you able to find it? Okay. All right. So we got that downloaded. And then you open up SPSS. All right. And to try to, my loading things are giving me problems. All right. And so I don't know if people saw this. I'll open it up again because usually you get a different screen. So let me open it up again. You might have a different splash screen that comes up. I want you to open up that file that you just downloaded, that 2018.
So it
Oh.
opens up in a window called Statistics Data Editor, right? Is that it's trying to do the right thing here?
Does it look like my screen? This now?
So I have both those things open. I have Welcome to IBM SPSS Statistics, and it looks just like yours. But then when I
Okay.
open the data set, it looks like a spreadsheet
Yeah.
with the cells filled
Um,
with ones, twos, and threes, and it's in a
I
separate.
usually just do this welcome to IBM SPSS and then
Okay.
like new data set.
Okay.
And you can go file, open, file, open, data, and then navigate to that data file.
All right, I think I've got it. The first one is ABANY. Yes.
And then, I mean, if there are other like SPS data sets open that are blank, you can just close them.
So SPS can also open like CSVs and XLSXs and things like that.
I believe so.
Cool.
Yeah, file, let's see, import data, yeah, import from CSVs, Excel, even SAS, yeah. Yep. So does everyone have this file open? David, yes, you said?
Yeah.
Khalil?
Yeah, I'm working on opening it.
I'm not able to open SPSS because I can't connect to the VPN. And I think it's like a tech
Oh.
issue on my end.
Claudia, is it
So
opening
I don't know if fellow
a
Mac
Safari
people.
window for you?
So like
Like-
what'll happen is like I don't know. Like I can't even get the VPN to open.
Okay, so I was having, so look, okay, in your upper right hand corner in that bar next to like say like the battery icon,
Okay.
you have a bunch of icons there. Like, do you have a zoom icon there, for example? Or I guess not, because you're using Zoom in the browser.
Yeah, I
And
have like a little
look for like a little globe icon. This is the same thing that was happening to me because Global Protect, it like runs in the background. It doesn't run like a regular app. So look around for like a little low-key globe icon. And that's your Global Protect. Here, maybe I can send you a screen.
If you bring it up on your screen, can you show her, David?
Oh yeah, maybe. But like I don't, like I said, I don't know because it's not. Yeah, I can't like screen share that because it's
Okay.
not a real. It like doesn't behave like a normal app. Um, it behaves like some kind of like something else, like something more secret. But yeah, for me, it's in the top bar. Like I can find it in the launch pad. Can you find yours in the launch pad?
No, so like do I need to first download it from the App Store? I'm sorry. I'm like always on campus, so I never have this issue.
Oh, you're so good. Yeah. Well, you download it from the web.
Okay.
I just had it open, so let me. I think I can throw the link for you in the chat.
And I don't know if you can see my screen where Alil put in like a screenshot of like the Global Protect.
Oh, nice. Thanks, Will.
Oh.
Yep. Okay. Maybe while you're doing that, Claudia, we can move forward while you work on that.
Yes. Yeah, go ahead and move forward without me, but
Okay. All right. So we talked about last time we opened this up and you can hit this icon here, which they coded both as numbers. Because like I was saying, sex is one of the columns in here and it's a 1 and a 2. And people take the mean of it. It's like, no, you can't do that. Or you can toggle between what the text is for the various fields. So this is an important values versus labels. This variable view here, click on that, and here's where you can see all the columns in the database. The label, you can see what it's trying to capture. So that first column is an abortion, if any woman wants an abortion for any reason. And then if you go over here and click on values and click on these 3 dots, you're able to see that, okay, a 0 means not applicable. That's what that actually means. A 1 is a yes, 2 is a no, 8 don't know, 9 NA. So this, when I was talking about how frequency tables, when you make them, you wouldn't want to include the NA column in there because they shouldn't be your total count. So whoever responded a 9 NA, you would throw them out in your frequency histograms and tables that you do. So something to be very, very aware of. You'll have homeworks where you're going to be asked to do frequency tables, and students always make the mistake and they include those. There.
Thanks.
Yeah. I just gotta not stop sharing. So, data view, this toggles back and forth. And then I was mentioning going to variable view. And here you can see the names. You can see the label. And then if you hover over this values, 3 little circles will come up, 3 dots, and you can click on that and figure out what is the values for any column in your database. Okay. I'm not sure what order you guys' database is in, but probably alphabetical would be the easiest for finding data. So, go up to edit and go down to options. And once you're there, you can look at this and click alphabetical here and display names. This will help in your interpretation of the data and when you go to find variables. So make sure that display names and alphabetical is checked. Okay, is everyone good with that? All right. Next, go to output. Okay. And for output, to help make things more readable, change this pivot table labeling to names and labels and variable values. This one, change that to values and labels. That will help. And then once we get those settings changed, click OK. Okay, that's fine. Okay, so some general housekeeping there. Okay. So, I kind of went over that. The main variables that we're gonna kind of be looking at with our time here are religion, how often people attend church, beliefs in post-life, and praying. And I have all of these steps by steps for you guys in the PowerPoint, so if something gets messed up, you can always come back to it. And so we're going to look at this religion one. So go to your variable view and go down to religion.
Jen, to clarify, what we're looking at is results of a survey.
Yep. So
About-
this
Okay.
is the GSS survey.
Yeah. Yes,
Yeah.
I'm with it now.
I think it's been done since 1972. So you can actually get the data since 1972, and it's just various social factors over the years. I mean, it's really weird some of the things they ask about in this data set, and I'll have you guys pick whatever fancies your interests. It's funny what people come up with. Some very interesting cross tabulations. But yeah, since 1972, questions asked by people in the United States. It's really neat and powerful. But we'll go down to religion here. Religion, I can spell H-I. Okay, religion. Okay. Let's click on the values, the value labels, and just take a look at them. Okay. So we can see that the 98 and 99 are all don't know. So those are kind of your missing values. If we click over here on missing values, we can see that it is set to the fact that yes, 98 and 99 are in fact the missing values. So if, we have to make some changes to missing values, this is where this would be. So I just got to that by clicking again on these 3 little circles here. Okay. All right, so let's, like we did in Excel, let's do some frequencies with this religion column. All right, so to do frequencies in SPSS, we go up to data. We go up to analyze, and then you go up to descriptive statistics and frequencies. So let me know when y'all got that up. Yep, David's good.
Can you say that order of clicks again, please? You go to data.
You go to analyze and then descriptive statistics and frequencies.
Well, I'm there.
Okay. All right, so we have this up and now put religion in there. So go down and find religion. There you go. Click on it and then the arrow throws it over in there. Okay. And once you have that done, you can click OK. And you'll have another window pop up. That will show you the count and the percentage and cumulative percentage. And it pulls your missing values out from your total count.
And missing values are,
People don't know what their religion is, or they didn't really want to answer that,
Okay.
or yeah,
non-responses.
yep.
And are we looking at did we select a year at some point?
This whole data set is just for the year of 2018.
Yeah. Thank you. Sorry.
Yep. There's no filtering going on. So is that everyone able to get this up? Okay. All right. Say you ran this analysis and you're like, oh, great, I want to save this. You can go up to File and then Save As. It will save it as a special SPSS file. And just like, navigate to wherever you want to save it and call it maybe religion frequencies. And then you can later go and open it back up and you'll have your analysis right there for you. So you can rerun it or refresh your brain as far as what you did like a year from now. Okay. So you can document what you've done. Okay. All right. So that's a quick introduction to frequencies. You can also edit this if you wanted to make it more informative. You can insert like a title to it. You can insert text to it. Say you wanted to make some notes about, the results of your analysis. You can also edit this before you go and save it and get some information there. So, yeah, frequencies are important basic way to look at data. Okay. So what if we wanted to look at multiple frequencies? So I'm going to close this out and you guys can too. We don't want to save it. But say we wanted to get frequencies for, at church attendance, post-life, and praying. So we want frequencies for 3 different variables. We can do those all at once. So again, go back to analysis, descriptive statistics and frequencies. Okay, everyone got that up? You get religion out of there. So we click it and we throw it back over here. So now find attend, post life, and pray. So
no more religion, but
no more religion.
But we want to attend post life and pray.
Yep.
For you guys, do the labels show in the frequency selection? I did do that options thing to have labels show up, but I'm not seeing them. I just have like the coded things.
Try right clicking. Just go over here and try
yeah.
right clicking and play with these.
Yeah, now they're here.
Okay. And once you get those thrown in there, just hit OK.
Can you say what they, all I'm remembering is post life and pray.
Attend, post life, and pray.
But those are all subsets of religion. So there'll be like R or religion and then
No,
things.
it's actually, you're not doing any cross tabs. It's just gonna do each of those frequencies on its own. So like it did attend on its own, less than once a year, several times. So in this database, 30% of people never go to church at all. In this database, 73% believe in an afterlife. So it's doing kind of the, you know, the frequencies for each individual variable.
Okay, but I mean for finding those variables. Like if I go to P, I don't see post life. So I'm expecting to see like religion space post life beliefs, but I don't see that either. How
Okay.
I don't know how to find these.
Is it sorted in alphabetical order? So you did, do you have it sort alphabetical order and display variable names?
Yes.
Okay. All right. And you're saying you don't see post life in there. Okay.
Well, maybe I don't know how to use the alphabet. That's possible. P E.
Post life is
Oh.
PO.
Yeah, so I see political party affiliation and Pope is infallible.
Do you see any of these other ones like popular posts? Do you have any POs?
Well, so I have it showing variable labels. Let me go back to variable names. Okay, if I go to variable labels, then I have all of those, but I don't know how to interpret them necessarily. But I do see post life now. Okay. And I do see pray. All right. That fixed it. In
Okay.
this part, it seems like you can't have it have names and labels, but maybe you can somehow.
Right. I mean, it's one or the other. So variable labels or variable names. Yeah.
Thanks. Sorry. And then the last one, attend. Yeah.
Yeah. Attend and pray. Yep. So this is kind of a way where, yeah, you can run frequencies for multiple different variables in your database.
Mhm.
Okay. Okay.
The things that the variables that show up with the different icon, the ruler as opposed to the dots, is that continuous versus coded data or something? Like,
Yeah. So you're looking like over here where you have like the little dots nominal, and then yeah, you have scale, which is a number. Yeah.
okay.
Age
There's
is also a
telling you-
number, but you can't really believe this all the way. And this is a problem with this data set is you look at sex.
Yeah, or
Sex
Hispanic.
is not nominal. Or sex is nominal, but
Sex
some
is
of these do have ordinal results, and ordinal really isn't used in here. So you kind of have to think about the data.
Okay.
Yeah.
Can't
It's
trust it.
Yeah, it's helpful for, is it a number or is it not a number?
Gotcha.
Yep. Okay. Let's see. We're near 8:15. It's at 8:15. So we didn't get as far as what I would like, but I think we probably should stop for the evening. Next time we'll pick up with this collapsing categories, because that's a very important part of data analysis. And like when we look at this one here praying. I mean, do I really need to have this many categories for how often you attend a church? I don't need to have this many categories. So we'll start to show you how you can recode the variables in something more manageable, because your frequency tables, especially once you start doing crosstabs, if you have too many categories, it's a nightmare. So we can pick up with that next week.
But with these things, can you, does it just store the amount of the number of responses to each question, or can you reference between the responses of individual? Like, can I find out the correlation between like people who have a reptile as a pet and their like spirituality, for example?
Yes, you can.
Oh,
You can do, yes, weird stuff like that with this data. I told you, students, that's kind of a crosstab. So when you're comparing, do people who, own pets have a different reflection on the afterlife? You can do those crosstabs and see if there is a relationship. And you can do the statistics to say, is this a significant relationship?
And then you could look over time and see what like the trends of I don't know, being sexually harassed are with, I'm just pulling things out at random, sorry, trigger warning, with having a turtle.
You could, but
Over
not in
time.
this data set because it's only 2018. If you download the whole data set, yes, we could do that. But I
Okay.
want to keep this simple, and it's a huge data set, so yeah. But yeah. You could do that if people's opinions about turtles and afterlife change over time could be done.
When you say it's a huge data set, is it huge just in like, it's a huge amount of data for sure, but the in terms of like compute, in terms of like memory storage, it's even the whole thing's kind of small, right? So it's all just text, or do the relationships make it actually like big in terms of storage?
Well, I mean, the thing that makes it big in terms of storage is the number of lines in the database, and the number of lines, I believe, is in the millions. Because, you have what, 40, 50 years of data. So those cross tabulations, those are outputs. They're not stored in the data. The data is how many records do I have? How many columns do I have? Which is big. And then once that gets larger, it takes more time to crunch those cross tabulations and statistics. But if you're interested, I can point you to the whole data set.
Yeah, maybe we'll start with this one. Yeah, I'm of course. All of a sudden, I feel like we have this godlike power to know things about people who have
Yeah. Okay. All right. Well, yeah, we got into SPSS and there is some homework on it. If you're running into the homework and it's not something that I covered, maybe look at the PowerPoint that I'm going to put up for this week, because I'll put the full PowerPoint on there with all my screenshots. But I think you should be able to do that homework because it's just basically trying to understand this data set. Okay. So awesome. Well, thank you guys for hanging in there tonight and having some fun with Excel and data. I'm excited.
Hey, thank you too.
Yep. Have a good night.
You too.